Thanks, Desio and A.B.E.L.H.A and others for organizing this symposium. I know it's too late. Hope you had enough coffee already. So what I'll do in the next 15 minutes is I think I changed the title a little bit, but not too much, I guess. I tweaked my title a little bit, but still the content is same as you see in the abstracts. I'll spend 15 minutes, I would say, or maybe 14 minutes, whatever Desio gives me from here on. Just for the audience that is non-US here, I just wanted to give an overview of pollination that happens here in the United States. So you see there is $17 billion worth of pollination is being done by honeybees here in the United States. About $656 million is the gross revenue that beekeepers obtain. It's a National Agricultural Statistical Services number. There are about 2.6 million colonies based on NAS statistics as of 2016. And there are about 90 to 130 different crops that are dependent on bees for pollination here in the United States. The interesting part here is for those who are non-US audience here, almond pollination, that's the largest crop that is dependent on bees for pollination here in the United States. And according to the California Department of Food and Agriculture, there is about 890,000 acres of bearing orchards. That means they need really pollination. And so there were about 1.6 million colonies that were employed in 2015, I would say, based on the data that Almond Board of California has. Just a picture to show you all the the pollination route that happens here in the United States. You can see a lot of movement of bees, the commercial bees from different regions and different states. But you can see on your left here, most of the concentration in February is in almonds, where 1.6 million hives are stationed for pollinating that 900,000 acres of almonds. Okay, coming back to our topic here. So major challenges, probably you are tired of hearing this already now, so many factors and multifactorial problem that bees have. So what I'll do is I'll just focus on some of those major ones that are affecting the commercial beekeeper colonies. So again, these are not in sequence, so I'll go with whatever sequence I would like, I guess. So parasites, pathogens, pests, pesticides, poor nutrition, and transportation stress is the unique one that applies to the commercial beekeepers, because those are the colonies that are moved when compared to the stationary ones that you see here in the United States. Again, probably you might have seen slides like these before. So none of these factors acts in isolation, right? So they are all, again, very complexly interacting with each other. So these are some common pests or pathogens or pests, whatever you want to call, that are encountered in the commercial beekeeper colonies these days. Varroa mites, nosema, all viruses that you're aware of, then European foul brood, American foul brood, and some states small hive beetle. Not all states have this problem, but some states still deal with that problem as well. So I'll just go over some of the studies that we have been doing at Oregon State, something related to commercial beekeepers. Again, I'm not showing you too many graphs here, but just to give a snapshot of what we do. So for the last 4 years, we have been conducting a long-term monitoring of colonies. We selected few beekeepers' hives in Oregon. There are about 10 beekeepers that are in the program. And so we monitor these hives. You see the numbers on those hives. So we follow them throughout the year. So they are frequently sampled in different crops as they go along. And then we are looking for pests and pathogens. We are looking for pesticides. We are looking for nutritional status as well. So these are a few things we are looking for along as they progress through the season. So again, this graph is just to show you a trend on what we see with varroa mite infestation levels. This is just a 1-year data that I'm showing you here. So that's kind of very useful information, not for us as well, but also for the beekeepers when we provide them such information, so that they know which months are the months when they should be more careful about the mite populations. This is, again, I thought, a good example how beekeepers can use this kind of data. You see, so this is in Central Oregon. There is a carrot seed pollination. It's a hybrid crop and very bad for bees because it's a nutritionally deficient crop in terms of both pollen and nectar. It doesn't produce much, as most of the hybrid crops do. So you can see first week of July, we took samples for the mite populations, and last week, so within 4 weeks, you see a doubling of the population of these mites. So that's the time that when they should be very careful. But unfortunately, beekeepers can't do much because this is still a pollination time. So what are these? So the slides I showed you, what do they mean? Is basically this is a practical challenge for these beekeepers in terms of management. So timely management of disease and treatment, for treatments of these is a problem, because not only just because they are a huge scale beekeepers. I know someone with 50,000 or 60,000 hives, there are beekeepers at that size, not in Oregon, but in other states, I would say. So it's not only easy to get to them on time for treating these pests and diseases, but also colonies are still in the crop, so they might be pollinating. Like I gave you that hybrid carrot example. So in June or July, they can't do much because they're still in a pollination setup. They're far from their home as well, probably. So it's not feasible always for these commercial beekeepers. And then sometimes the nectar flow. If a beekeeper is in a honey production situation, so nectar flow is on, and then there are not many miticides that you can use when the honey flow is still on or nectar flow is on. So these are a couple of important things that are kind of impediments for commercial beekeepers in treating those pests and diseases in time. And then the other one is disease transmission, or pest transmission as well. So spread of pests and pathogens, of course, probably if you're a stationary beekeeper, you may not be dealing with that problem much, but if you are a migratory beekeeper, like the commercial operations, and especially, again, almond pollination, where there are 1.6 million hives sitting in just one region of California, is a problem. And I know we really don't care much about these things, and you talk to a beekeeper, for them the pollination is important. They don't even think about transmission of pests and diseases. So this is a good example I'm giving you here. Small hive beetle, again, as I said, it's prevalent in several states, but not in Oregon. But I see that wherever we talk to our commercial beekeepers, I've been getting several reports of this every year. But that's on and off. It has not been it hasn't established here in Oregon, but still we see those reports from probably May until October, and then we don't see that beetle. And that's another one, the one I listed as the sap beetle. It's an Australian sap beetle, Brachypepalus basalis. We have been seeing this for the last 2 years in Oregon. And again, I think they are not established in Oregon, but whenever the beekeepers go and sit in California along with other beekeepers from Texas or other regions, there is a good chance, because most of these beetles are very good flyers and they can get into these hives as well. So what people have been doing about all this is basically we have, I think Natalie talked about the Bean Found partnership. So we have a tech transfer team at Oregon State as well. So BAP has, I think, 4 or 5 tech transfer teams. These are the ones that have been established to help commercial beekeepers to monitor their colonies. So what these guys do is they go to these beekeepers very frequently, at least once in 2 months, and they take samples for pests and diseases that they have, even sometimes for pesticides, and even for virus analysis in some cases. So that's been a very valuable service for these beekeepers, because they can't do that if it's a large-scale operation. So these teams have been very valuable, and I think they have been very popular as well these days. So these are 2 guys, Dan and Ellen, with the Oregon State University. In their position description, they don't have to wear the bee beards, but still sometimes they do those things too. Pesticides, again, as you know, when you're moving into different agricultural cropping systems, there is a good chance of being exposed to pesticides, and that's been happening a lot. As you might have seen this study from Mullen et al. 2010, high levels of miticides and agrochemicals were reported. Then you might have seen this study as well that came in very recently, a couple of weeks ago. Trainer et al. Has shown that in a pollination setup, the colonies had these pesticide exposures, higher exposure when compared to the stationary hives that were in holding yards or in honey production locations. Another study, Pettis et al. 2013, you can see pesticide exposure. They have shown that those that were in the cropping system, they were exposed to Nosema serrana and had problems as well. So again, there are a few studies that have been done on that scale recently, but here this is the one where we also at Oregon State, we followed these 4 different crops which a commercial beekeeper in Oregon pollinates. So you can see, so this is the first crop, almond. You can see several fungicides, and there are some herbicides as well. And then cherry crop is the next one with a couple of fungicides and herbicides and organophosphate. Meadowfoam is an oilseed crop, not a huge one, but still there is some insecticide applications in there along with some acaricides, and so blueberry again you can see some. So again, the bottom line is, these commercial operations are not anyway immune to any of these problems, because when you are in a cropping system, you should expect, again, I'm not saying all these are harmful for bees, or these are all in parts per billion if you pay attention to the numbers here. But again, just for, it's pretty. And then I'll go, do we have a few more minutes this year? Or?
5 minutes.
Okay, 5 minutes. I think I have too many slides, so I'll skip faster. So nutrition, as you know, there is no, I can't emphasize more for nutrition, because that's one thing which probably is having some control the beekeepers have, as well as we can do something about it. So I just have in this slide how important bee nutrition is. Again, you can see all these reports, USDA, Honeybee Health Summit, BIP surveys, everyone has emphasized that bee nutrition has an important role to play in bee health. And then several studies have shown that optimal nutrition will boost immune system, detoxifying enzymes, and this was a neat study that came out in 2013, where these guys have shown that coumatic acid is present in pollen, and you can see it upregulates these detoxifying genes as well. So nutrition is very critical, and sometimes we tend to ignore, and nutrition, I think, still is one of the areas which has been very much understudied. So I'll focus more on quantity, quality, and diversity of pollen. I'll not go much into nectar, which is also an important source for nutrition. So again, this is one of our studies that we have been looking at. One of my graduate students looked at the diversity of pollen in these different cropping systems. So you see all those crops on your left, and then you have the mean percentage of the target crop pollen. You see almond in February, nothing else blooms in California except almonds. There might be some weeds around like dandelion, but so it's 99% pollen is from the target crop. Then we have cherries, about 53. The blueberry one is surprising. You don't get much. If you have worked with blueberries in the past, you know bees don't collect much blueberry pollen. It's mostly the weeds around at the time. So you see, again, the bottom line here is there is so much so much variability within the cropping systems on how much pollen they are getting and what kind of diversity they are getting. So that's important to understand as well. We have been testing some of these pollens as well for protein content, so I'm just giving you a few here. I may have missed some here. So you can see again, all pollens are not made equal. You can see the crude protein content is very different in different pollens. So some of them might be pretty good and some of them are not. So this graph is, again, I took from one of our studies, again, just to emphasize why different pollens are important. So you see the diets on the lower axis here. So diet 1, diet 2, they're based on the diversity of pollen. So this is going according to the gradient. So diet 1 is basically a monocrop, it's almond pollen. So you can see the hypopharyngeal gland protein content is lower and significantly different when compared to the other 3 diets. So again, just to show the digestibility of the pollen is very critical as well. So not all pollens are, even if they have a crude protein level high, that doesn't mean that always it's good. You might have seen a lot of initiatives since 2014, since the presidential memorandum came. There is a lot of emphasis in increasing habitat for bees, nutrition for bees. So this is one project we are doing with the Almond Board funded project. So agencies like Project A.B.E.L.H.A, mellifera, some of you might have heard, they are promoting these nutritional crops, such as this is a rapini, which is a type of mustard. And so again, so here I was talking to one of the speakers, earlier speakers, and I said that there is this obsession about planting things. Always something that is attractive doesn't mean that's good, right? So it might be a source of nectar, or it could be a source of just pollen, so there's so many things to understand. So the whole idea about this study is to quantify the physiological parameters. So what we are doing in this study is wherever these almond farmers have planted this rapini, we are trying to place hives where this rapini is there and where the rapini is absent. We are trying to look at physiological parameters from hypopharyngeal glands to immune system of the bee to several other things, including colony growth. We are doing something in Oregon as well. That's a carrot seed I mentioned. It's a hybrid crop, not very good for bees because it doesn't produce much nectar and pollen. So we're trying to plant something as hedgerows for bees. I'll skip this one because of time. And the transportation, again, this is an area there is a lot of gap in knowledge. No one really knows how transportation affects bees. And now we talk about physiological effects and all this when they are restrained in trucks and moved. So there are only a couple of studies I was able to find. One of this says transportation and pollination resulted in higher nosema levels. And then there is another study that came out in 2012 which says transportation affects hypopharyngeal gland development in bees. And the last one I have here is queen losses. Again, this is not a scientific study. A lot of anecdotal evidence. You talk to these commercial beekeepers, they move their hives. So each time they move, that's a number they give me, is they lose about 10% of their queens each time they move from one pollination event to other. So of course there is a physiological physiological stress, but again, no one has really quantified this. So this is one area of research probably someone should do. I think I am almost done. Thank you very much.